Hi again, I'm Nick Kridler. And, thanks. And I'm going to be talking to you today about a Python package that I've developed called Pyxley. And it's designed to make it a little bit easier to stand up some dashboards or web applications with Flask and React. So a little bit about me. I'm a data scientist at a women's fashion company called StitchFix. We're based in San Francisco. And we have a very large algorithms team. I'm part of the merch algorithms team. And prior to StitchFix, I worked in defense for a better part of a decade. My background's in applied math. I also spent some time in healthcare. I did a lot of data science competitions on Kaggle. And in fact, I won 2 of them, both whale competitions. If you're interested in learning more about how to detect whales, we can talk afterwards. But yeah, so I'm not a front-end person, but having come to StitchFix, part of my job is to create dashboards to share data with our business partners. And so I've started to get involved a little bit. And so, like I said, our algorithms team is gigantic at StitchFix. We have something like 50 people now. It's really quite amazing. And so how StitchFix works is we have a website. You go there and you create a profile. You say what kinds of clothes you're interested in, what's your size and color preference, all those kinds of things. And then we have an algorithm that does recommendations. They're all fed to a stylus. The stylus picks 5 things, and it ships to the customer, and the customer tries them on at home, keeps what they want, and then sends back the rest. Right? And so we have many teams to work on these things. Styling takes care of the recommendation engine. We have a data platform team that helps us build tools for us. Client algorithms handles things like marketing and operations. And then the merchandising algorithms group handles things like inventory optimization. So how do we know, or how do we optimize planning and buying and all of those things? And product development, so how do we find the right items that should be even in the recommendation engine in the first place? So it's been a lot of fun. But like I said before, we have to present data to our business partners, in this case, the buyers and planners and things. And you know, presenting data to them is usually the first step towards answering any of these bigger questions. Right? And so having worked in defense for a number of years and working with physicists, I'm used to delivering plots, like really beautiful charts and things, but our merge team loves spreadsheets and tables and drilling down and like inspecting every aspect of things. And so I'm still trying to get them excited about plots, but for now I just need some way that they can like drill down and look at the data. And so Shiny is a tool by RStudio. It's written in R, and that's what they used when I started at StitchFix. So we still use today, and it does the job. Here's an example I've taken from their web page where you can see you can filter a bunch of things and then get this table and look at the data. And it's really great for making simple applications. And how we use Shiny at StitchFix is we take cached CSV extracts. So we have the data refreshed daily by doing extracts against our production database. They feed into this like directory that serves up these Shiny apps. And then when our business partners on the merch team, they log into the dashboard, they're able to look at drill downs and tables. And unfortunately, like as these things get bigger, because it's in R and the way that it's structured, and maybe we're not even using it the right way, but it's hard to debug, and it's really difficult to add custom JavaScript, and it's really easy to mess up. In fact, you know, when I started, I inherited other people's dashboards, and I don't know if you recognize this emoji, but it's a table flip, and so it can be really frustrating to just get someone's wall of text code that is not really, you know, a coder, but like built this gigantic dashboard, and it's just a mess. And so what I really wanted was a lightweight web application where I could do my data prep in Python, where I can use pandas, and to be able to integrate with arbitrary JavaScript libraries. So here's a screenshot of an example I have, and big. So what I wanted, so here's some Fitbit data of mine that I've thrown into a simple app. But what I wanted was something where I could click a button, things would change dynamically, and there's not much overhead. Behind this is a one script, or one file app in Flask. Right? So this is what I was looking for. And at the time, there were a couple Python options. I looked into Bokeh and Spire, which gave you the ability to write web applications in pure Python. You basically got Matplotlib in the browser, which is kind of nice if you like Matplotlib and are used to that framework. And they both are able to integrate well with sort of minimalistic web frameworks. But at least it wasn't obvious to me how easy it would be to integrate custom JavaScript. And so I sort of started with just messing around with JavaScript, and these did not seem to be the options that I was looking for. So then there was this blog post by the folks at realpython.com, and they had this post about the ultimate Flask front end, and it talked about using React with Flask and Gulp and Bower and these things. And it's a great blog post. I definitely recommend visiting it. But this sort of got me started with using React. And so the one thing that I like about React is it's only concerned with the UI. And so I can integrate it with Flask. I don't have to worry about too much overhead. The organization is really nice, so you can just create these components that are hierarchical, and you can basically make layouts of other components. And so compositions are pretty easy, and it's fast because you're only dealing with rendering things that are actually changing. And so a very simple React component, you write like you would HTML, and so you write these JSX files that are transformed and compiled, but it basically lets you mix JavaScript and HTML. And so here I've created a filter component where it only takes in two properties, a type and an options. And so this gives me like an entry point where I can pass in data from Python. And I only have to supply the type and the options, and React is going to handle the rest. And so to abstract it a little bit more, what I've done is use a factory pattern where I create a bunch of things that conform to a specific pattern. So filters, right? So like drop downs, slider bars, anything where it has a particular state that I want to capture. And I make it conform to this pattern, and then when I create it in Python, I just tell Python that I want to create a filter of a certain type, and I specify it with options. And so then I use the Python dictionary to handle specifics. So you might imagine like a simple drop-down button where you would have a label, the different options, and then like maybe this is something that's feeding off of like a DataFrame or something, and so maybe you want to have a like alias to a column, or and then like a default value. And so you can like then write a simple wrapper. So here I've got a select button, which is a filter, and I specify the different parameters. And then so when I call it, I get something like this, where I say I want a select button. It says click me. The two options are A and B, and then this is the background information. So when I click it, I get a drop-down menu. And so then I integrated I added a wrapper for the metrics graphics library. So I'm not sure if any of you are familiar with metrics graphics, but it's a great charting library written by the folks at Mozilla. And the API is really nice, so it was really easy to set up just like a simple wrapper where I could basically model it sort of the way that Matplotlib is. I create a figure. In the figure, I pass in information about where I'm going to have an API sending data from, and then a element that I'm going to mount to. And so here I'm just calling it my chart. And then there's a bunch of different graphics options, layout options, and then I create a line chart where I specify, here I've got some data frame, and I'm specifying some initial parameters and some things that I want to plot. And so eventually, I'll have there's some example code, but it produces something like this, where you pick an option, it hits the API returns new data, and then it updates, right? And then so it has animated transitions. So if I pick another one, it's really pretty. And so how does this all work? So if you're familiar with the ModelViewController Web Pattern, or pattern for web applications or web stuff in general, so you have the model, which is like your data storage. And in my case, I'm using just simple pandas data frames. The UI, which is all React, is the view. And then the fetching data part for the UI is a controller. And so Flask, I'm using to manage the data and the APIs. I've created some abstractions so that way you can just say, I want a plot, and it'll go and connect all the pieces in the background. React is a bunch of filters and charts. And then what I'm calling Pyxley is actually just a bit of glue. It's just the things that are helping each of these pieces talk to each other. And so filters and charts, so for my purposes, they're all I really need. I just need a way for the folks on the merch team to specify some component of our inventory that they want to look at, and then suddenly they're presented with that. And so when I say filters, I just mean drop-down sliders. Again, it controls the state of the chart. And then charts are any visualizations of the data. So a table, a plot. And all of these things are set up so the way they're going to retrieve their data through an API call. And so then I was thinking about, OK, these are all the things I want to do. What can I actually do in Python? And so I can create and mount React components. I can wrap reusable charts and filters. And then I can hide the request routing from the user. And so that's all that Pyxley does. And it uses Jinja templating to create one single React component. So the library is constructed in such a way that you can have a single React component that has an entire layout composed of lots of other React elements. And then in the Python, it just goes in and fills in wherever you have the base template or layout, and then whatever parameters that it needs, and then the element that it's going to bind to. So the charting, I have a bunch of different JavaScript charting libraries, and the wrappers work like this. You have the specific parameters. I've left out some assignments and things, but basically whatever your parameters are for a plot, a line chart. And then there's a get data function, and this tells it what to do when it receives the data request. So when the particular API route is hit, this is what we're going to do. We're going to apply some filters, and we're going to return a JSON response. So in this particular case, I pass all of these things to the base class, and then it knows how it should function. And so I only have a few libraries to start with: metrics graphics, data tables, data maps. I've started putting in some NVD3, but it's not too difficult to add new classes or new libraries. And so coming up is documentation. Still working on that. Some testing, integration with more libraries and more widgets and things. I use this at work, and so as I'm creating new things, I check them in. And so if you'd like to contribute, here are the links. It's StitchFix, Pyxley, our GitHub repository. And then my Twitter handle is Kridler. That's my GitHub repository as well. So I use Pyxley in this presentation. So it's an HTML presentation. I was able to drop in Pyxley components without any problems. Thanks. That's it. Any questions?
Your original motivation was based on the fact that some of the existing stuff didn't give you enough access to modify the JavaScript?
Yeah, and to drop in. So the tables, I mean, so some of the dashboards that I have are like a combination of charts plus like other HTML like elements and things.
So which framework would you recommend for someone who just wants Python backend with an asynchronous charting front end, but doesn't want to touch JavaScript at all?
So Bokeh seems like a pretty solid. I mean, I haven't been tracking it really closely, and when I first looked at it, it wasn't anywhere near what it looks like today. And so, I mean, at second glance, it looks pretty cool. So I definitely would start there, I think.
What's the data object that you're actually handing up to React via the template?
You mean the JSON?
The template tag bars.
Yeah.
What are you handing up? DataFrame?
Yeah, it's a dict. So it's just each of the different filters and charts just keeps one dictionary that then in my like layout just goes through all the charts that you've added to the layout and makes one gigantic dictionary and pushes that into it. Yeah. Oh, sorry. Well, this one up front and then.
One of the major headaches that I was running into was the way that the data was basically being consumed by whatever charting
Yeah.
framework it was.
Mm-hmm.
Sometimes it was just like an array,
Yeah.
and the array was the ordinate or, or the y-axis or whatever it was, right?
Right.
So it depended on those arrays being in the right order and corresponding to each other, right? Matching
Yeah.
each other or something. And then there were others that were dictionaries, and that was a lot more workable, right? So,
Mm-hmm.
but I was wondering, is there some reason you just didn't use D3 for everything? Because it's just such a big.
Well, I wanted to sort of minimize the amount of JavaScript that I had to write because I'm not a JavaScript developer, and I like sort of I can hack something together. Yeah.
Because the other frameworks that you're using, what was it called, metric,
Mm-hmm.
those are JavaScript as well, right?
Yeah.
But I'm just thinking that D3 is just a lot more uniform.
So a lot of the ones that I chose are actually based on D3, and so that's why in the specific implementations of the like the wrappers that I wrote, that's where it specifies how to pass the data through. And so I'm still trying to come up with like maybe a little bit more of a generic way to do that. And so right now the way it's set up is that like the chart holds the specific implementation of how the data will be transformed and then sent as JSON. But certainly I can see where it'd be useful to have that be like arbitrarily defined later. So I don't know. I think. I guess is your question to have like one like unified way of sending the data, or?
Well, I just, yeah, because the more different sources and
Yeah.
frameworks that you use, it just turns into just such a pain.
Yeah.
Publishing to the web, right?
Yeah.
Just a complete pain. You can't remember the ways that each framework in its own kind
Yeah.
of particular way is deciding that it wants to merge the data
Right.
with the behavior, right? So,
Yeah. Well, I mean, I don't know. I wasn't quite sure of a way to get around that, so it just is. It is what it is. Yeah. You had a question back there? Oh, okay. Cool.
It seems like you can get up and running with Pyxley quite quickly. Is
Mm-hmm.
that right? You just specify Flask application, just have some JSON, you can just write it right. And with
Yeah.
Pyxley, it's right there with React components.
Yeah.
Have you played around with like pulling the JSON like in the browser rather than like injecting it into the template and then sort of sending that all up at once?
I haven't. So the way that I specified the options for creating the different charts and things is through the like props part of the React component. And so the data that gets written out there is typically much smaller than like so it's not necessarily the data that's in one of these plots. Right?
Oh, okay.
So this stuff is all handled through the APIs. The only stuff that's passed through in the template is like the title and then like I think like the element name and things like that. So it's much smaller amount. Any more questions? Well, thank you.